So we are now into this third webinar of the series, surge protection devices. Earlier we had discussed about importance of connecting wires, impulse current rating, backup fuse in the earlier two webinars. In this webinar, we are going to discuss mostly about the communication SPDs, why we need communication SPDs, what type of SPDs we need to install, what are the component inside the communication SPDs. Because already in India, SPDs are somewhat a neglected subject, and out of this neglected subject, communication SPDs are even more neglected. A lot of people, lot of industrial people, they don't even realize that they need the importance of communication SPDs are as good as power SPDs. So before starting with the communication SPDs, we'll just brush up what we had discussed in last two webinars as well. So these are the various standards for surge protection devices. IEC 61643 Part 11 2011, which is testing standard for low voltage surge protection devices. IEC 61643 Part 12, which tells about the selection of power SPDs. IEC 61643 Part 21, which is a testing standard for communication SPDs. IEC 61643 Part 22, which gives the selection of communication SPDs. Again, IEC 61643 Part 31 and 32, which are mostly for solar PV SPDs. Again, one is a testing standard. Second one deals in the collection of SPDs. Now it has to be noted that same IEC 61643 Part 11 and Part 12 has been adopted by IS also as IS 16463 Part 11 and Part 12. Okay, lightning protection standard IEC 62305 Part 4 also gives some details about surge protection devices, whereas IEC 60364 Part 5 Part 53 gives how an SPD should be installed in an electrical system. So these are the various standards for surge protection devices for both power as well as communication. Again, in last webinars, we have studied that there are basically two types of impulses. First one is 10 by 350 microsecond waveform. Second one is 8 by 20 microsecond waveform. 10 by 350 microsecond waveform, in the common name, we also call it as a lightning surge, whereas 8 by 20 microsecond waveform can also be called as a switching surge. Based on these waveforms, there are two types of SPD classified. First one is class 1 SPD, which can withstand lightning waveform or lightning impulses, which is nothing but a 10 by 350 microsecond waveform. Second one is class 2 SPD, which is nothing but a SPD which is tested with 8 by 20 microsecond waveform. So based on these type of waveforms, SPDs has been classified into two types, class 1 and class 2. Now we are going to see how an SPD is collected in an electrical circuit and how it operates. So this is a typical 3+1 connection shown for a 3-phase 4-wire system or 3-phase 5-wire system, as we may say. So we have a 4-pole SPD, SPD 1, 2 and 3, which is connected between 3 lines and neutral. And then we have SPD 4, which is connected between neutral and earth. This is called a 3+1 connection. Similarly, there is one more connection which is called as 4+0 connection, in which all 3 lines and neutral is directly connected to earth. So just for the sake of understanding, because we already have discussed this particular thing in the last webinar, just for the sake of understanding, for the catching up, we'll just discuss this thing. Let us imagine there was a surge, and due to this surge, our earth goes to a very high potential. Let's see, the potential of earth reaches to, let's say, 10 kV. Now, in this case, there is a potential difference between PE and neutral, which is more than 1500 volt. 1500 volt is nothing, but the voltage protection level of SPD 4. That means as soon as voltage goes more than 1500 volt, SPD 4 will start operating. So here in this case, as you can see, neutral is at 10 kV, just an imaginary value, 10 kV. So there is a potential difference between line and neutral and earth of 10 kV. Due to this potential difference, SPD 4 operates, it creates a short circuit. As soon as it creates a short circuit, the voltage which was only at earth previously now reaches to neutral also, because as we all know, in case of short circuit, voltage becomes same. So now our neutral is at a higher potential, earth is at a higher potential, but our RYB is still at the same potential. Now, but you can see now SPD 1, 2 and 3 can experience some potential difference, which will be more than 1500 volt, or which will be more than the voltage protection level of that SPD. Because of this potential difference, SPD 3, 4, 1, 2, and 3 will operate simultaneously, and our whole system will be at the same potential. So our main purpose of using an SPD was to create an equipotential, and this way we are going to achieve equipotential by the use of SPD. Now, again, the major, most important thing about this whole operation was this complete thing happened in few nanoseconds. Generally, the fastest available SPD in market is 1 nanosecond, and even up to 25-100 nanosecond is acceptable. But the best possible result would be 1 nanosecond. So all these things happened in a few nanoseconds. Okay. The second major point we had discussed was the effect of lead length. This is what we had discussed in the last webinar. Suppose we have considered a 1 meter of cable, and 1 meter of cable has impedance of 1 microhenry. On the right side, you can see a graph which shows DIDT for 3 different impulses: first positive impulse, first negative discharge, and subsequent impulse. So we can see that the di by dt will be very, very high. So in case of first positive impulse, the di by dt will be around 20 kiloamperes per microsecond. That means per microsecond, the rate of change of current will be around 20 kiloampere. Now, we all know that voltage is equal to L di by dt. L is nothing but the impedance. Impedance in this case is 1 microhenry. So in case of first positive impulse, the di by dt was 20 kiloampere per microsecond. So the total voltage drop across 1 meter of wire is around 20 kV per meter. Similarly, in case of first negative discharge, di by dt was 100 kilovolt per meter. Now, once we consider impedance to be 1 microhenry, the potential drop across 1 meter of cable, 1 meter of wire length would be around 100 kV per meter. Similarly, in case of subsequent impulses, L di by dt, if we consider the same formula, L di by dt, 1 microsecond will be the impedance, and the di by dt as shown in graph is around 200 kiloampere per microsecond. Voltage drop will be around 200 kV per meter. So you can see even a 1 meter of wire, which is generally what we use in our electrical system while connecting the SPD, can cause up to 200 kV per meter voltage drop. Practically, it may be a little bit less or a little bit more, but still it's very high value. This is one of the major problems which we are experienced while connecting an SPD. This is a few photograph of how we are connecting an SPD. You see the length of wire, this connecting SPD, even we cannot see where it is going to terminate. It will be around 4-5 meters. The reason being, the existing DV does not have a space to accommodate SPD. So once we don't have a space, what we do is we put a separate box for SPD, and then we use around 2, 3, or even 5 meters of wire. Now, in this case, do you really think this SPD is going to work? No. If we use an SPD with 5 meters of wire length, it is not going to work. Now, then what is the solution? How do we overcome this problem? So we had discussed that in the last segment also. The solution is busbar mounted SPDs. These kind of SPDs can directly be mounted on the earth busbar. As you can see in the bottom figure, this can directly be mounted on the earth busbar. Hence, the wire length can be reduced by a huge extent. Apart from that, these SPDs have a very multiple advantages, like they have large thermal capacity electrodes to absorb heat during the surge. It has a very strong aluminum housing. So in case of failure or during anything, it prevents any kind of explosion. This is packed with a pressure of around 1,500 plus pounds that results in very low dynamic resistance and higher conductivity of the SPD. Since it's a metal, there is no fuel to burn in case there is a fire or in case there is an explosion or something like that. Anyways, there won't be any explosion because of strong aluminum housing in this case. Plus, it has a response time of 1 nanosecond. It is warranted for 10 years. Again, we had discussed at length about this particular models, how this is going to, once we use this kind of SPD, we can be assured that our system is protected, because now these SPDs are connected in parallel. Even the Dindale SPDs are connected in parallel. We have to physically go and check whether SPD is working or not working, because it's not a tripping device or it won't trip after every surge. So by using a Dindale SPD, we are liable to check every 5-6 months about the working status of the SPD. Whereas in this kind of busbar mounted SPDs, we are not really, we should not be worried about the working status because it is not going to fail. Probably it is not going to fail. We are giving a warranty of 10 years and expected life of 20 to 30 years, at least in Indian conditions. The second parameter, okay, this is one of the graph which shows the voltage drop. Now we had discussed about the voltage drop across the wire length. So we have shown 3 graphs. Out of this, 2 are for the strikes of series SPDs, that is the busbar mounted SPDs, and third one is for the DIN-rail SPD. So you see, once the surge current increases, the lead through voltage across SPD will be very high. For example, for a 40 kA surge current, a DIN-rail mounted SPD will have an effective voltage protection level of around 16 kV. Whereas on the same surge current, a busbar mounted SPD will have a voltage protection level of very less than 2 kV. So in all the cases, even if the surge is of a very high rating, our system, our equipments are protected. The second issue, second problem what we discussed in case of SPDs was the use of backup fuse. Now, SPDs are, as discussed, one of the most sensitive devices in the electrical network. It has a response time in nanoseconds. Again, it is connected between line to neutral and line to P. Now, during the event of SPD operation, it offers a very low impedance, almost like a short circuit. Now, just imagine we have connected an SPD as shown in the diagram. Now, after the end of the life of SPD, let's say 5, 6, 8 years after that, SPD has failed. Now, there is a probability that SPD can fail in a short circuit mode. Once an SPD fails in a short circuit mode, there will be a short circuit current which flows from the line or from the power source through the SPD into the earth or neutral, probably into the earth mostly. So this short circuit current will have very high energy. So this energy dissipated during the conduction of this short circuit current is very high and can cause a fire hazard. So generally there is a thermal disconnector inside the SPD for the same purpose, but it has certain limitation, it has certain rating. So every manufacturer will provide a certain rating of the main fuse, this main fuse. Once the rating of this main fuse goes more than that certain value, the SPD needs an additional fuse. This additional fuse will provide a security, or it will provide safety in the event of SPD failure. This failure can be due to aging, or it can be due to a temporary overvoltage, it can be due to leakage current, or it can be due to follow current. Like in case of spark gap, due to follow current, there is a strong possibility of generation of short circuit current. So this kind of short circuit can be provided by putting an additional backup fuse. Now, this is one purpose of this backup fuse. If we read IS 732, they have explained some other purpose also, some more purpose also for backup fuse, that is to achieve priority to continuity of supply or to achieve priority to continuity of protection. Because if you see this example, if you see this figure, this is the equipment to be protected. We have connected SPD with a fuse. Now, in case there is a SPD has failed, there will be a surge current which flows through the fuse, and due to that, fuse gets blown off. Once the fuse gets blown off, this SPD will be disconnected from the supply. Hence, the equipment will get a continuous supply. This is the first case where we are ensuring continuity of supply with the use of backup fuse. Second case is priority to continuity of protection. In this case, we are not using any backup fuse in series with SPD, but we are using a fuse in series with the line. If you see, during the event of this SPD failure, during the event of short circuit, this fuse will blow. Once this fuse blows, it disconnects the equipment from the supply. So here, the supply is disconnected to the equipment as soon as SPD fails. That means in any case, your equipment is going to get protected. If you want supply to be continuous, or if you want to give supply to the equipment, you have to replace the SPD. So for the critical equipment like PLC, UPS, where you don't want your equipment to be unprotected, even the fire alarm panel, we can use this kind of, we can use backup fuse in this way, so that our supply will be, our protection will be continuous. So these are the two basic use of, another two use of backup fuse. One, to ensure priority to continuity of supply. Second, to ensure priority to continuity of protection. Now, third case is if we want both priority to continuity of supply as well as priority to continuity of protection. Now, in this case, we use a SPD with a redundant feature. That means inside one SPD, there will be two fuse and two SPDs. In case SPD 1 fails, second SPD will be connected and will keep on protecting your equipment, and supply will also be continuous throughout the equipment. Now, how do we achieve this? To achieve this, we have to use a SPD with this kind of surge protection device, which has a redundancy inside it. This kind of SPDs have basically two protective components inside each plug, so that once the first component fail, second component immediately will come under operation. It has a 3-stage time indicator. That means in normal SPDs, the flag indication is like green means SPD is working, red means SPD is not working. Whereas in this case, SPD will first go from green to yellow, and then it can go from yellow to red. Additionally, these SPDs has a short circuit rating up to 50 kiloampere. Now, there is one more problem with thin rail SPDs, the other conventional SPDs available in the market is there is a lot of confusion about the backup fuse. People don't know what they need to install as a backup protection. Sometimes they'll install MCB, sometimes they will install even MPCB as a backup protection. Plus, there is another confusion about what rating backup protection need to be used. So, to ensure that there is no confusion, no wrong product has been should be used, another product has been developed by us, which is an SPD with an integrated fuse. So this is an SPD with an integrated fuse. It has our patented phase EDT technology. It can offer a safe behavior under lightning condition. It is not going to fail. It is not going to explode. It is not going to catch fire. It's a fuseless design. With the fuseless design, you can save a lot of space. A lot of money can be saved. Again, due to no fuse, there will be lesser connecting wires, less complexity, lesser space, and lower cost. Again, it's a reliable connection device. It has an impulse current of around 25 kiloampere per pole, line to neutral in case of 3+1 connection, and neutral to earth in case of 3+1 connection, it will be 100 kiloamperes. Apart from that, one of the major advantage it has is it has a short circuit rating of around 100 kiloamperes. So once we use an SPD with an integrated fuse, short circuit rating becomes a very important parameter, because if we use this SPD in a main incomer panel, sometimes they have a fault current of 65 kiloampere, 80 kiloampere. Even 65 kiloamperes is very, very common. In those cases, 50 kiloamperes SPD, the short circuit rating of 50 kiloampere will not work. We have to use an SPD with a short circuit rating of 100 kiloampere. So this is a class 1 SPD with the integrated fuse. Again, these are pluggables. You can just, if one plug fails, you can just easily replace the plug itself. You need not to replace the complete setup. Now this is type 2 SPD or class 2 SPD with an integrated fuse. Again, this is also pluggable. It will also save you a lot of space because there is no fuse involved. It has a nominal current of 20 kiloampere per pole. Again, it also has a short circuit rating of 200 kiloamperes per pole. So that is going to help you a lot if you are using an integrated fuse. And it has a response time of 25 nanoseconds as well. So this is what we had discussed in the earlier webinars. So we had just brushed up a little because it's been a long time. I think 2-3 weeks back we had the last webinar. Now we are going to discuss one more parameter, which is called the impulse current. Again, a lot of people have asked this kind of questions. What should be the impulse current in an SPD? How do we decide the impulse current in an SPD? So we have considered two types of connections, a 4+0 connection and 3+1 connections. So we can consider, now there are general conceptions also, and then you can do the risk assessment also. So once you do the risk assessment, let us suppose your building comes in a lightning protection level 1. So we all know that lightning protection level 1, expected lightning current will be 200 kiloampere. So as per the standard, out of 200 kiloampere impulse current, 50% of the impulse current goes to the ground. Remaining 50% of the impulse current will come back again to our building through earthing or through any other means. So in case of level 1, we can expect that maximum expected surge current, this is the maximum expected surge current we are talking about, will be around 100 kiloamperes. So in case of 3+1 connections, we have to ensure that neutral to earth plug will carry this whole 100 kiloamperes. So it should be rated with 100 kiloamperes. Whereas line to neutral plug in 3+1 connection can be 25 kiloampere. Similarly, in case of 4+0 connection, where all three lines and neutral is directly connected to earth, there this 100 kA current will be divided into three lines and one neutral path. Hence, per path or per pole, impulse current should be 25 kA. Similarly, in case of level 2, expected 50% of the expected impulse current would be 75 kA. So line to neutral and line to P in case of 4+0 and 3+1 connection would be around 18 kA, whereas neutral to PE in place of 3+1 connection would be around 75 kA. Then again, the buildings with level 3 and 4, buildings which fall under level 3 and 4 will have an expected surge current of 50 kA. So in case of 4+0 connection, this 50 kA will be divided into 4 parts, and hence each pole must be able to withstand around 12.5 kA. Whereas in case of 3+1 connection, line to neutral will be around 12.5 kA, whereas neutral to earth, since it has to carry the complete current, would be around 50 kA. So this is how we should be selecting an impulse current for a building, because this was one of the major doubts of a lot of people. A lot of people have shown interest in this particular slide while selecting the SPD. Now we'll discuss about the fundamentals of telecom signal and data line protection. Generally, when we talk about signal transmission, so signal transmission can happen in two ways. First can be in a differential mode signal transmission. Second, in a common mode signal transmission. What differential mode signal transmission means? Suppose there are two wires carrying signal A and signal B. If the transmission is between the two wires A and B, then this is called a differential mode signal transmission. Whereas if the transmission is between a common reference between signal A and signal B, this common reference can be shielded earth, or the functional earth. If the communication is between two lines and this common point or the common reference wire, then it is called as common mode protection. So surges, common mode signal transmission. So surges may come in common mode transmission. Also, they can come in differential mode transmission. Again, not only common and differential mode transmission, here we have shown an example of differential mode communication. Though transient can be of opposite polarity also. You can see two line A and line B, two type of two signals. So that the transient can be positive side as well as negative side on the line B. And same, the positive transient will be clamped on the positive side, whereas negative transient will be clamped on the negative side. Again, now this in the last slide we had discussed about the communication line, but transients on the power line may also be common on differential. Here is the example of a common mode in a power line and a differential mode in a power line. In the common mode for a power line, the current will be in the same direction for both live conductors as well as neutral. Whereas in case of differential mode for a power line, live conductor and neutral will carry current in opposite direction. So even the transients can come both in the common mode as well as differential mode. Now, this is what can happen to our integrated circuit if we are not using surge protection device. I am sure people from the industrial background might have seen this picture earlier, because I have seen it multiple times. I have seen multiple times electronic devices are failing. So this is what can happen if you don't use a proper, if you use an unprotected data circuits. So Mr. Gordon Moore, who was the founder of Intel, has given a law which says that the number of transistor junctions in an integrated circuit doubles approximately every 2 years. Now, this is a graph from 1971 to 2011, which shows that in 1971, the number of transistor junctions were around 2,300 in a single IC circuit, which now has reached to up to 2.6 billion in 2011. That too, again, it was a 10 years back data. Now also the things have increased. The number of transistor junctions have even increased now. This is what called as Moore's law in terms of microprocessor and transistor counts. Now, since the number of transistors, number of components are increasing, the size of the IC is decreasing almost, you can say every day, or like it's decreasing over the period of time. So if we see in 1950s, our electronics equipment were able to withstand around 0.1 up to 10 joules of energy. They were able to withstand. So they are giving certain energy to this electronics equipment and withstanding, and they were noticing how much they can withstand. Now, in the latest year 2020s, the equipment which were able to withstand 10 joules now can withstand only up to 10 to the power minus 8 joules or 10 to the power minus 9 joules. The reason being, the sizes of electronics have been reduced in a greater way. For example, we can see our televisions. Earlier, they were very thick CRT tubes were used, and now we have flat screen LED TVs. With the reduce in size, the insulation level also decreases. And once the insulation level decreases, it is very the equipment can fail very easily. Even with a small amount of energy can fail an equipment, can destroy an equipment. So this is the type of components which are generally used in a signal line SPD. There are three common components which are used in a signal line SPD. First one is air gaps or gas discharge tube. Second one is metal oxide varistors. Third one is silicon avalanche diode or silicon diodes, or it is also called transorbs. In some way, sometimes it is also called as transorbs. So we have taken three properties: the energy withstanding capacity, the residual voltage, and the follow current. In case of gas discharge tube, they have a very good energy withstanding capacity. They have poor residual voltage. That means the operating voltage, the clamping voltage will be, spark voltage will be little high, and they have a problem of follow current. Whereas in case of metal oxide varistors, they have a decent energy handling capacity, a decent residual voltage, or decent low spark voltage, and they don't have a follow current problem. Similarly, in case of silicon diodes, so silicon avalanche diode, they have a very poor. They can handle very low amount of energy, but they have very good residual voltage. The clamping voltage is very good. They operate at a very low voltage. Plus, they do not have a problem of follow current. These are the three components generally used to protect a data and signal lines. And these are the properties of these components. Now, these are the characteristics of these components, of this non-linear component. You can see that GDT is clamping at around 3 to 4,000 volt, whereas residual voltage across the metal oxide varistor is around 800 volt, and residual voltage across silicon avalanche diode is around 600 volt. So the clamping voltage for silicon avalanche SAD is least, whereas MOV is little bit higher, and GDT has a very high clamping voltage. So to protect a normal equipment or normal data equipment or signal protection, various components are used together to give the optimum protection. This is an example of such kind of device, where GDT, a metal oxide varistor, and a transorb, also known as diodes, have used to give the optimum protection. Now, this kind of protection can be achieved in stages. It is very important to ensure that there is energy coordination between all three equipment, GDT, metal oxide varistor, and the diodes. Now, you see stage 1, stage 2, and stage 3. In this kind of circuit, as we know, the fastest or the least clamping voltage is for the silicon avalanche diode. So once there is a surge, silicon avalanche diode, the SAD or the transorb will operate faster. So once it operates, let's say there was a surge of 10 kV, and this transorb has a clamping voltage of 600 volt. Now it will particularly clamp that voltage up to 600 volt. Now, in this case, we have to ensure there's a proper energy coordination between the other two devices also, because once this transorb clamps the voltage, other two equipment will not work. So for that purpose, there is a small impedance. It can be inductance or resistance is given between stage 2 and stage 3. The purpose of this impedance is to create a voltage drop so that stage 2 devices also trip. Similarly, stage 2 and stage 1 also there is an impedance which is given, which ensure the operation of GDT also. So for example, stage 3, transop operates at 600 volt, whereas an MOV operates at 800 volt. So we have to put the impedance in between stage 2 and stage 3 so that it creates a voltage drop of around 200 volt, so that our MOV also operates. So once MOV operates, again the GT, let's say, operates at 1200 volt or 1400 volt. So in that case, we have to ensure the value of impedance in such a way that voltage drop across that impedance will be around 600 volt. So once the voltage drop is 600 volt, so 600 plus 800, it becomes 1400 volt. So now our SPD, our GDT, which was for which clamping voltage was 1400 volt, now operates. Now these values, I've just assumed the values. It will change again from case to case. It is going to change, and for the same reason, the value of this impedance become very important. Now, a lot of people have this question: why can't a single MOV or why can't a single SPD can be made for all the applications? Now, because of this reason, there are multiple models. We have multiple models for multiple operations. For example, for Ethernet, we have different model. For RS-232, we have different model. Even RS-485, we have different model. In RS-485 also, we have 5 to 6 models, like for paired light or for other shielded cables. For all the things, we have different kind of SPDs. That is, we have to use a different impedance for different application based on the frequency and the requirement of the system. So a good manufacturer will have different models with different impedances. Now, if a manufacturer claim that it has a universal SPD that works for almost all the communication or signal, in that case, probably that particular manufacturer will be using a gas discharge tube, and other two components will not be used in that device. And for signal and communication line protection, GDT has typically a very high voltage clamping rating. Hence, equipment will be under very high stress. It will experience very high voltage even during the surge timing. Below, we have shown a graph which shows that first one is about the response time. Response time of GDT is the slowest. MOV is faster than GDT, and transop or the diode is faster than MOV. Below that, there's a graph about the energy handling capacity. So GDT can handle the highest amount of surges. MOV can handle little bit lesser surges when compared to GDT, and diode can handle very less surges. Now, because of this energy coordination, the maximum energy will be going through the GDT, and very less amount of energy will be going through this transop or the silicon avalanche diode. Again, this is also a graph which shows the stage operation of energy coordination. During the SPD operation, the GDT, the red color area, the amount of energy handled by GDT is very high, as shown in the figure. MOV will handle a little bit lesser energy, and diode will handle a very less energy. And the white color section is the final residual voltage across the equipment, which is very, very less. Once we use the stage energy coordination, once we use these three components in a coordinated way. So again, this is a pictorial representation of operation of these three devices, GDT, MOV, and diode. First one is a normal a normal surge, which is around 8 to 10 kV. GDT will clamp at a 600 volt level. Now MOV has little bit lesser clamping voltage, which is around 100 volt. Whereas diode will have even lesser clamping voltage, which is around 40 to 50 volt. And final residual voltage across the equipment will be very less and around 20 to 25 volt, which our equipment can stand very easily. This is an example of how a device can be used using these three combinations. They have gas discharge tube at the stage 3, stage 1. Then there is a MOV with parallel circuit of resistor and inductance for the voltage drop. Similarly, there is a diode on the stage 3. On the 1, 2, there is diode on the right hand side. Left hand side there is GDT, and in between there is MOV. In case of operation, first this diodes will operate. Then there will be some voltage drop across this series component coordinating elements. After that, our MOV will operate due to the voltage drop. After that, again, there will be some voltage drop between the other components, and then our GT will operate. GT is going to handle the maximum amount of energy, which will ensure that our diode is not stressed, and diode will ensure that very less residual voltage goes into the equipment, which will ensure that our equipment is not going to be stressed about the voltage. This is a normal clamping performance of a 12 volt transient barrier of a diode. We had applied a 6 kV 1.2 by 50 voltage microsecond voltage waveform with a current of around 3 kiloampere 8 by 20 microsecond. So we can see that the clamping voltage for the diode was around 10 volts. It's just a pictorial representation. It's just a graph. So this is a typical CCTV circuits, analog CCTV circuit. This is how we have shown by an example how we need to connect SPDs. So for this kind of analog CCTV operation, we are using three kind of SPDs. First one is a power SPD for the electrical distribution panel. Then we are using a coaxial SPD for the coaxial cable which is going into the monitor. And third one is the communication SPD for the control panel. Now, this has to be noted here that this is just an example. There is no surety that in real life it can be digital CCTV operation also. They can use a LAN wire Cat6 cable or any kind of communication can be used. This is just an example of how communication SPDs can be used. Similarly, there are three buildings in a let's say in a plant. There's a main building, then the filing station, then a production plant. Now, a lot of communication will be happening through these buildings. Now, this communication can be through LAN, through RS485 to 4 by 20 milliampere communication, or through any kind of bus. So, for each and every application, we have to ensure that we are choosing the right product, we are selecting the right SPD, and hence we are ensuring that equipment is free, equipment is safe. It's not failing. So there are multiple SPDs are available for the protection communication lines. For example, Red Hat SLH2 and SLH4. It's like a universal data SPD which can protect almost all kind of lines. In this kind of SPDs, there are two particular models are available, which are a 2-pair and single pair, like a 2-wire for a 2-wire communication system and a 4-wire communication system. Now, similarly, if the lines are symmetrical or if the lines are balanced, we have another model called Red Hat SPH2 and Red Hat SPH4. Then we have another SPD which is Red Hat SGS3 series and Red Hat SPHP series, which are modular and which can be used if there is a separate signal ground. If there is separate signal ground provided in the communication, if there is separate ground wire, then we can use this kind of SPDs. Then we have another model SUI4, which is a modular 2-pair SPD for exposed line, which has a very high impedance of around 5 kiloampere per pair. This again we are going to study on the next slide also. Then we have another model called Red Hat SSH, which can be used for the shielded cable. Then we have another model which can be used with RC contact, which are available with RC contact. And then we have this compact series SPDs, where in some places we have very much space constraints. The space is not that much in the PLC panel. There is very less space. We don't have a space to provide this kind of thick SPDs. There we can provide this universal compact SPD, which are available for the 2 lines as well as for the 4-line communication. That means for a single pair as well as 2-pair communication. Similarly, multiple SPDs are there. In that, if you see the model on the middle one below, it is one of the important models for this oil and gas sector. These are the, it is like for M20 gland compatible SPDs for the explosive environment. Especially in the oil and gas, they have these field equipments where they need threaded, they have this threaded type of port where SPD need to be installed. So these SPDs are normally installed in this kind of environment, explosive environment, and gas sector, even the water and sewer treatment plant. That also we have in the next slides. So this is a normal, some of the parameters about the normal rated SLS series SPD which we had discussed. It is tested as per IEC category D1, C1, C2 and C3. It has a nominal discharge current of 10 kiloampere and a maximum discharge current of 20 kiloampere. The impulse current rating is around 2.5 kiloampere per line for a per pair, actually per pair of communication. For a single pair communication, the impulse current will be 2.5 kiloampere. For the two pair of communication, the impulse current will be 5 kiloampere. Load current is around 1 ampere. Now, for the communication point of view, this load current is very high. Generally, load current will be much lesser than 1 ampere. It will be in milliamps. It has got an integrated thermal protection and it has got a very high cutoff frequency of 30 megahertz. Now, frequency also plays a very important role while selecting a data SPD. We have to ensure that the SPDs which we are selecting has a proper frequency range of the communication system where we are going to install these SPDs. Similarly, we have a rated SPH model which is available in 2 line and 4 lines. It can handle, now the advantage for this particular model is it can handle a high operational current of around 10 ampere, which is very rare, but again, it is possible. There are some applications where this high current is required. It can be used for balance as well as symmetrical lines. Now we have again different kind of models with rated SLL, then rated SSH, which can be used for Profibus, Synec L2, CAN bus, RS232 and RS485. Then we have rated SSH, which can be used for shielded cable. Wherever we are using a shielded cable, the rated SSH can be used. This is also available in multiple voltage, 5 volt, 12 volt, 30 volt, and other series SPDs are also available up to 96 volt. They even 110 volt also it is available up to 5 volt to 110 volt. We have SPDs for communication line. Now all these SPDs for communication lines are UL listed. Now these all are tested with ICVD as well as underwriter's laboratory to give you the maximum protection required. Now, this was the other segment was for the SPDs which can be used for our communication like for RS485 communication, that kind of data communication it was used. Now a lot of places the communication is happening through LAN connectors or maybe a Cat6 cable, or in case of our switches or CCTVs, LAN is used. For protection of LAN, this kind of SPDs are used. These are Cat6 compatible SPDs. Again, this comes under IEC category D1, C1, C2 and C3. It has a MCOV of 50 volt line to line and 72 volt between two pairs. It is PoE compatible, power over Ethernet compatible, can be used with Cat5 cable, Cat5e cable and Cat6 cable. It has a nominal discharge current of 10 kiloampere, 8 by 20 microsecond waveform. And it can also handle an impulse current of 1 kiloampere, 10 by 350 microsecond waveform. Now we have to, in this case or other data SPDs also, the thing is very less impulse current is expected inside the communication line. It will be maybe because of the coupling, radiation, and very less conductive surge impulse surges are expected in the communication line. Hence the impulse current value is not that much because only partial lightning current is going to come there. Again, for this particular model also, load current is around 1 ampere. It has a cutoff frequency of around 250 megawatt, which is quite high considering the Indian communication frequency in case of LAN. And if you see the connection diagram on the right hand side, you see between each pair of line, we have used a protective component to ensure that you get the refined protection. The equipment which is connected with particular SPDs are very safe, especially the equipments like PTZ cameras or the Ethernet switches, which are very expensive and very sensitive. These kind of SPDs can be used to protect those equipments. Now these are Chrome SPDs. These are available as 10 pair of Chrome connectors. Normally, a lot of time during rainy season we have seen, or even after the rain or thundering, we have seen that there is some noise problem in our telephone lines in the industries and all. That is due to the surges in the Chrome network. So we can use an SPD for Chrome network that can be able to protect us. So it has a nominal current of 5 kiloampere. It has it is rated under IC category C1, C2, and C3. The maximum discharge current, maximum discharge handling capacity is 10 kiloampere. Now load current in case of telephones is very less. It's around 0.3 milliampere. Now this thing has to be noted. This 0.3 milliampere is for the per GDT. It is per GDT. Now this picture which is shown is for a 10 pair communication, 10 chrome pair. That means 10 lines of chrome can be protected with this particular product, and each line will have 10 kiloampere of maximum discharge rating, and each line will have 0.3 milliampere of load current. Again, the cutoff frequency is also very high, up to 30 megahertz. Response time is 100 nanoseconds for this particular product. Now, these are coaxial SPDs normally used for RF antennas and all. This is available. Like I'm sure everybody might have seen this kind of coaxial cables. Like for example, N-type cable, F-type cable, BNC type connections, UHF type connection. There are multiple type of connections. So we have surge protection for all type of connections. The voltage ranges up to 70 volt to 280 volt. It can handle a peak power of 40 to 300 watts, which is again a very high value for the small SPDs. The nominal discharge current of 10 kiloampere, maximum discharge current of 20 kiloampere. It has a very low insertion loss of less than 0.4 dB, return loss less than 20 decibels. Cutoff frequency generally is 2.6 gigahertz, but we have models which are available up to even 6 gigahertz for a special application. Like we have been regularly giving this product to Indian Army. So especially on the areas at a very high altitude, like in Jammu and all, they have this their transmission going on. They have their what is the right word? They have this chalky and something on the mountain. So they communicate with other services, other places through these radio transmitters, and they were experiencing a really common failure. So once we had supplied this kind of product, this kind of coaxial SPDs, the failure in their segment was practically zero. Earlier, without SPDs, they were experiencing failure almost every time there was a lightning or thundering. So this was just a case example where I had given where this kind of SPDs were used, and it was used and the problem of the client was solved. In this case, client was supposed to be Indian Army. Then again, this is what the communication SPDs were. Another important thing is, how do we measure and record an SPD? Now we have installed an SPD. It's a parallel device. It operates and it regains its original position. Now, how do we come to know that how many times SPD is operated, or how many times our SPD has protected our equipment, or how many times SPD has protected our equipment? For that, we can use this kind of surge event recorder, which can be placed near to SPD, which will record the number and time of the surges. For example, you have installed this kind of event recorder near to let's say your main incomer panel. So now in this recorder, you will be able to see how many number of times the surges have come. So you can have a data about the observation, that in a year, like you can have a data in a year, how many numbers of surges you can expect in your system. This kind of measurements you can do. Now these have these recorders have LCD screens. It has an integrated battery, lithium battery with a 3 years of battery life. Now this battery can be replaced also. It can record up to 999 number of events. And once you reach that 999 numbers, again, it is going to be a long time till you reach that number. After that, you can just reset it. Again, it will start from 1. It is like a 2-pole device. Its size is around double pole size, 35 mm. It is dindle mounted. It can be easily mounted on the dindle. Now, it has a threshold current of 50 ampere. That means as soon as there's a current of 50 ampere, as soon as this device monitors or it just counts the current of senses the current of 50 amperes, it will count it as a surge. The maximum counting discharge current it can have is around 50 kiloampere. Now this can be achieved. Actually, this sensing is achieved through a CT, but it's a special type of current transformers. It's a special type of CT because it is going to measure the surge which is there in the system for a very short time, let's say 8 by 20 microsecond, even very small 50 ampere current also it will detect. So it's a very special CT used for this application. Then we have a lightning recorder, which is our Cape Make Roller Basic. Now this can be installed in a lightning protection system on the down conductors. To if you want to know what is the how many numbers of lightning strike your building experience and how many times your system has worked. So it has a threshold current of 1 kiloampere 10 by 350 microsecond. That means as soon as a current of 1 kiloampere passes through this counter, it is going to count it as one event. The maximum discharge current, the maximum capability for it is around 100 kiloamperes. Again, for a level 1 lightning protection system, the maximum expected current is 200 kiloampere, which again will be divided, let's say, in minimum 4 numbers of down conductors. So maximum expected current is around 50 kiloamperes only, but we have given 100 kiloamperes as the maximum counting discharge current. Now, this is a surge tester or SPD tester. Now, this is, I am sure it's quite a new product for everybody. Now, let's say we have in all the SPDs have some kind of leakage current, or all the SPD, it will experience some internal changes with time. For example, voltage protection level for an SPD will keep on increasing after each surge or due to some leakage current. The voltage protection level will increase. In case of spark gap, due to the melting of the point two terminals, this voltage protection level will increase. So we can use this kind of tester. It's a universal SPD tester. It can test all kind of components. Once you once you connect an SPD through across this tester is going to tell you what kind of component is inside the SPD, whether it's a GDT, whether it's a MOV, or whether it's a silicon avalanche diode. All these components, three components will be tested by this tester. Plus, it will tell you what is the current voltage protection level of the SPD. For example, there was an SPD installed near to a very critical equipment. In the flag indication, it has not failed because internally it has not disconnected. But due to some aging or due to leakage current, some other reason, the voltage protection level has reached as a very high point. In that case, your equipment may fail. Or let's say you have installed 200 SPDs and those 200 SPDs after 3 years or 4 years, you want to check the status, whether it is actually still what is the voltage protection level of that SPD. In that case, we can use this tester and it is going to save you a lot of cost because you need not to replace all SPDs worth 30 lakhs or 40 lakhs, whatever the amount you have installed. So another advantage with this particular model is it can test SPDs of all the manufacturers. There is no, it's not like only this particular make SPD it can test. It can test SPDs with all the manufacturers. It can give you the log mode also. You can use the log mode. There's a TFT display touchscreen interface and it's a very easy interface. You can easily, a normal person can also be can also use it very easily. It has a inbuilt rechargeable battery. You will get a charger also along with this tester. It is very light in weight. It is very compact size. It can be easily carried in hand. It's not a bulky device that has to be carried by a very difficult means. It can be carried very easily. Now, this is a SPD monitor. Like you all know, earlier also we had discussed in the earlier webinars. All the SPDs will have some kind of leakage current, which will again increase with time. So after a certain amount of time, this leakage current can create SPD failure and can give a shock, or it can prove to be dangerous. So once we use this kind of monitoring device along with SPD, it will immediately tell you what is the leakage current of the SPD. It's a 3-pole device. For all the 3 plugs, it can tell the leakage current. So it can measure even a small leakage current of 100 milliamperes. So it has a lithium battery with a life of 2 years. It has again a remote contact also with 1 ampere rating. It's also a 2-pole device with 35 mm width. It can easily be installed. It can be used for all kind of SPDs. It's not like for a certain SPD only it can be used. So these for the different monitoring and counting equipments we can have for surge protection devices. Now we have given an example for certain places like this particular case. We have taken a mobile base station and we have shown how many SPDs we can install. In a typical mobile base station, we have a class 1 SPD, a class 2 SPD in sub-distribution board, class 1 SPD during the point of entry to the building, then coaxial SPDs, then again sun lightning counter for your lightning protection system, SPD live monitoring, leakage current device, isolating spark gap for creating the equipotential bonding, for connecting two earthings where the actual connection is not required during the normal operation. Again, this is one of the this is also one of the product, isolating spark gap for equipotential bonding clamps also it is called sometimes. For example, in a building, you have an instrumentation earthing or cleaner, and it has to be connected with electrical earthing. Now, most cases, instrumentation earthing, people want to keep it separate and not connected with the electrical earth. There we can use this kind of isolating spark gaps, which can be connected in between these two earthing. In the normal operation, this will be disconnected completely separate from each other. Only during the event of fault or lightning, these two earthing will be connected. So you will get the equipotential during the event of lightning, and normal state it will not be connected. So similarly, a photovoltaic system, a class 1 SPD, class 1 DC SPD need to be used in the combiner box. Class 2 DC SPD need to be used near to the inverter. Then communication SPD need to be used in photovoltaic system, because in the photovoltaic system you have monitoring system, string monitoring system, which gives you the current value of each string to the inverter. For that communication, we need to give data signal line SPDs. There are a lot of LAN connections also available. We need to use Cat6 SPDs. SPD live monitoring devices, we need to use surge counter, lightning counter. Then on the AC side, after the inverter also, SPDs can be installed type 1 and type 2. For the wind system, again, we can use SPDs for TNS or TNC system. In the wind, normally in the distribution board, there is no neutral. So we have to use a 3-pole SPDs for that. Then again, we have to use a different RS-45 communication SPDs. LAN communication also happens there. For that, we need to use a Cat6 SPD. Then we have to use a lightning event counter. We should use a lightning event counter in the transformer station. We need to use a class 1 or class 2 SPD based on the application. In the main distribution board, we have to use a class 1 SPD. Again, that is based on the application. Generally, in the auxiliary control cabinet, there is no neutral generally. So they use only a 3-pole SPD. But again, it will change case to case. Sometimes 3+1 SPDs also can be used. Now, surge protection for the nozzle of the wind turbine. Again, this is also a case-specific requirement. Multiple SPDs are used. Generally, this particular application has a voltage of around 750 volt or even 1000 volt. So this kind of SPDs need to be used, which has around line to earth or line to neutral voltage of around 550 volt. So the line to line voltage will be 750 or 1000 volt. Again, there will be some transmission or data signaling will be happening about the temperature and wind speed measurement. And this temperature and wind speed measurement details is transmitted through RS-485 or other modes of communication. For that, we need to use a communication SPD. Then for the oil and gas segment, we need to use a multiple SPD like class 1 SPD, class 2 SPD, isolating spark gap, as I explained earlier. In this particular segment, again, normal threaded SPD can also be used because it's an explosive environment. Sometimes they have field equipments which need a SPD with threaded connections. Again, same SPD monitoring devices along with lightning counter can also be used here. For the buildings, main distribution board class 1 SPD has to be used, and for sub distribution board class 2 SPD should be used. Inside the building, there will be multiple communication happening with the LAN, RS-45, RS-232, communication cable, low voltage SPDs with explosive area attack certifications that also need to be provided. There are SPDs available with integrated filters, integrated noise filters that also can be used. The wastewater measurement, again, class 1 SPD for the main distribution board, class 2 SPD for the sub distribution board. Then inside this water management or sewage treatment plant also, there will be multiple communication happening with LAN or maybe RS-45, RS-232. All these lines has to be protected. Then if you see the serial number 7 is that the threaded SPD, threaded point SPD. It can be used for explosive zone. Same is also generally used in water management plant. We are also supplying a lot of this kind of plants. Railway stations, they have multiple requirement like IPS panels. In the main distribution panel, you can use class 1 SPD. They have telecommunication network. They have LAN connection. They have RS-45 connection. Generally, in the integrated power supply, they have this 3.110 volt power supply that also need to be protected. Axle counter, they have this kind of protection that also need to be protected. And again, this will change case to case. We need to ensure that all the lines, all the places are protected. The similar arrangement is there for the biogas plants also. For the main panel, class 1 SPD. For sub-distribution board, class 2 SPD. For signaling, RS-45 SPD with a ground cable. Then if there is a shielded cable, RS rated SSH need to be used. Then for LAN communication, Cat6 SPD need to be used. Surge and lightning counters should be used wherever required. In normal industrial facility also, there will be a main panel where we can use a class 1 SPDs, distribution board class 2 SPDs. We have to ensure that critical panels like fire alarm panel, lift panel, all these panels have proper surge protection. For the internal communication, for the switches and CCTVs, Cat6 SPDs can be used. Again, for supplies given to the PCBs and switches, sometimes the DC 110 volt or 24 volt, 3648 volt DC supply is given. For that, type 3 DC SPD shall be used to ensure that there is no failure. So this is it from my side. I've tried to explain in the best possible way about all the applications, all the SPDs I've tried to explain. Still, if you have any questions, you can ask in the question answer box. So here I am ending my presentation. And thank you for the opportunity given to me. Thank you, Dominic sir, Gopakumar sir, and all the participants for this opportunity.